Okay, so we are solving problem 69 from chapter 2 from Giancoli 6th edition. So what we have is a stone is dropped from the roof of a high building. Okay, so I'll call it my stone A is dropped from a high building. Okay, a second stone is dropped, but later. A second stone is dropped 1.50 seconds later. So let me erase this stone here and let me say the following. Once this stone A is already down here after 1.50 seconds, another stone B here is dropped. Okay, so let me erase this A here. My A is now here. 1.50 seconds have passed, and that's when ball B is finally dropped. Time passes and these balls are going down, and after some time passed, ball A is already down here and ball B is already down here. What we know is that the speed of ball B is now 14 meters per second. What we want to know is how far apart these stones are. Okay, so what we want to know is what is this distance here. In other words, what is XA, the position of ball A, minus XB, the position of ball B, when ball B has that speed 14 meters per second. So this is our question. Okay, to solve this problem, let me choose a reference frame. I'm going to choose this vertical line. I'll say that down is positive. Once I do that, I can say that my G, which is always pointing down, is going to be plus 9.8 meters per second square. I'll also choose this point as being the origin, so the initial positions of both balls are 0. The initial velocity of both balls are 0 because they are just dropped. And let's try to solve this question. Let's try to find this distance between these two balls once my ball A has that speed 14 meters per second. So let me start trying to find what is the position of ball B when it has the velocity 14 meters per second pointing down. How am I going to do that? Well, I can try to use that equation for position. X equals to x naught plus v naught t plus a over 2 t squared. Okay, so the initial position is 0. I don't need to put. Initial velocity is 0. I don't need to write in anything. And the acceleration is plus 9.8 divided by 2. And now I'm in trouble. I don't have the time. So what am I going to put here? Well, I do not have the time, but I have information about the velocity. I know that the velocity at that point, the velocity of B at that point is 14. Okay? And I also have this equation for velocity, which is the initial plus AT. The initial, I know it's 0. The acceleration, I know, is 9.8. So from here, I can get the time. And the time that we obtain is 1.22 seconds. So I know that after 1.22 seconds, ball B has the speed of 14 meters per second. Once I put this time back here, I can find out what is the position of B. And what I find is that the position of B is 7.29 meters. Good. So I'm done with one part of my question. Now I need to find out what is the position A. What is the position of ball A when ball B already reached 14 meters per second? I know that ball A left started its motion much earlier, 1.50 seconds before ball B. So I'm going to use again this equation for finding positions. Okay. I know the position of ball A initially is 0. The velocity is also initially 0 because it was just dropped. So all I need to play with is the acceleration. So this is equal sign here, right? So I have the acceleration 9.8 divided by 2, and now comes which time? Well, this time that we found here, 1.22, is the time for ball B, but ball A was moving earlier. So the time for ball B is that 1.22 seconds, which is what ball B needed to reach 14, plus the time that ball A was already moving. Ball A has been in the air for longer than ball B. Ball A has been in the air for 2.72 seconds. Okay, so with this information now, this is squared here, I can get what is position A for ball A is 36.3 meters. And now I can go on and find what is the distance between the two, XA minus XB. And we find this is 29.0 meters. So this is the answer of our problem.